Okay, welcome back. So let's continue with the airfoil. So as you have seen, we have covered a lot, many techniques. Okay, this is a quite cool technique. No, I like to use, as I mentioned, creating the background mesh and then the STL on top of an STL. So we have covered all this refinement, restart in parallel, a lot of stuff. Now let's focus on boundary layer, which is the most problematic part. So let's generate the boundary layer. In this case, let me reduce the same. Always I will focus now in M4, but the same techniques will work with any of the cases or any geometry. So let's take a look at the output. So simple case, there is not much going on, but as you recall in the one that I put the refinement level 6, it was a lot information on the screen. No, so what I want to show you here that you have all the steps now when you're doing the meshing. Let me go precisely. Okay, here. Okay, check mesh everything. Okay, and here. So if you look here, bam, 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 specific writing mesh step 2. So the body fitted ended, and as you read here, you will see that there is a lot of information. So you can take a look at the quality metrics. You can do some debugging to see what is happening. I have to say that I have done a lot debugging in Snappy to understand how things work. So I have my own version that I modify to get fully no boundary layer coverage and to solve problems. But there is a problem that we're going to see in the mesh. It's a conceptual problem on the technique that is being used. But yeah, I modify it to solve some issues. But yeah, you take a look. But let's focus in the boundary layer meshing. So look at that here at the beginning. It's reading the quality metrics, so it's going to enforce this quality metric. So you have iterations and so on. So remember that you have many options. So I invite you go back here and see all this and relax and so on. So it is just iterating just to improve to trying to enforce that. So if you use values too low, this might take forever. It's not going to likely it's not going to fulfill that requirement, but it will try to do its best. So these are standard values. Okay, so if you want to disable, I just show you how to do it. Here we have enabled. But then also some other information that is already telling you a lot. And what is interesting here is doing this iteration. These are checking the boundary layer. We're in step 3. And look at that. You have these quality metrics. And it's telling you that internally, and that stuff is defined. Remember that you have, mesh quality, so you can define that. So later we're going to see that changing something might fix problems. And you have there some information. Okay, nothing bad. Okay, so everything is okay. But this entry is a very interesting entry because here it's already telling, according to the parameters that you gave me, you want 5 layers, your near wall distance will be this, and the overall thickness is already telling that information. Okay, and this is very important. Okay, and then at the end also is giving you the coverage of the thickness, percentage that you are covering your surface. So ideally is 1%, 100% is everything. Personally speaking, more than 90 is okay, but you need to see if you have those problems, boundary layer collapsing in critical areas. If you are not in critical areas, it's okay. And also we have seen that sometimes this can lie, so you need to always visualize. But I want to point out these are standard geometrical regressions that you're doing here, how everything is computed. So here I will show you an Excel file that you can download also. And this is part of the debugging I was doing, and I have a lot of information. I know how things work, okay? And when I have all my quality metrics enabled, what is the limit? Okay, what point I can reach, and after that point, I will need to disable some metrics or modify something. So look at that what we have here and using the technique. So let me go back and open here the snappyHexMesh dictionary. So in this case, it's here, this one. And what I'm doing, there are different methods now, so combinations. So you have there. So I like to use the final layer thickness. Now that means that the final layer of your geometry will have a percentage of the cell next to the geometry. So kind of is defined here, 0.5, 50%, your expansion ratio of the boundary layer. In the boundary layer, you can control that. Unfortunately, you cannot control that in the Cartesian mesh. And then you define, that's all, the number of layers. So this one should be commented because I don't have it. And we're done. So look at that, and based on this information, and I know how to compute those progressions. For this case, remember my base mesh cell size is 0.125, okay? And just to remind you, let me open Paraphone. It's not 0.5 like in blockMesh, 0.15 because blockMesh, and then we add these refinements. So you can measure, it's not, you are not sure, you can measure that. So just to show you that here in sources measurement, you have ruler, you press P, insert a point, and then the external, and there you go, 0.05, and see that you have the other. Okay, roughly speaking, no, I'm not being super precise, so I go here, here, and here. And there you go. Okay, so this is the distance, and then you do all the snappy will do all the magic at the surface level. So you have the distance, I have the refinement 4, so roughly speaking, the surface edge will be like this. So it can be a little bit smaller, larger, but roughly speaking. Percentage of base cell size 50% that define, and that means this. Let me go now and move here. Okay, I'm basically telling in that case that the final layer 1, 2, 3, 4, 5 have 50%, not the height of this one. Probably 70 is a better value. Definitely, I don't recommend you to use 100%. So it's up to you. Personally speaking, I feel like 50% is a good value, but you can change it. Okay, so this is what happens. So it's this one, and again, if you are in doubt, we can measure. Let me measure this one here. Okay. Also, this one, the one I okay, sources measure runner. Okay, let's see here to here. Roughly speaking, is this one. This one should be half 0.34, something like that. Let me go. There you go. Okay, so that is what is happening. Then when I was talking as well about the growth rate in the background mesh, look at that. That cannot be controlled. You go from, and let me show better. Okay, you're going from this big to something small immediately. So usually you add these cells for all matters. These are polyhedron here. So probably it's better if we look at, let me see this. Okay, so this is a poly for all matters. Now, so you have what I call it hanging now, but this is a poly with 1, 2, 3, 4, 5 faces. Okay, in this plane at least. And what is happening that your transition from this to this, and this is a fixed transition of 2. And you go from that one, and then you go into smaller one from 2, and look at it here also, that fixed transition. And that is one of the main problems that you have in a Snappy or any meshing tool that used this technique, okay? So that's why you have a lot of problems here, in particular, all problems here. All these quality metrics start to be conflicting among many sense, okay? So there is nothing that you can do there to control that. However, the boundary layer can be controlled. So that being said, we have an idea what is happening. You can control things not using this one. So using the final relative, by relative I mean the percentage. You can also use absolute, which is pretty much it works in the same way, but I feel like I have more control with relative. So here I can a priori know what what is my limit? So based on the quality metrics that you are enforcing in a Snappy, your limit here you have, I have a few quantities, but you have this one, no? This ratio, which is near wall distance, no? Which is the ratio between last layer and your current layer. And this one have to be less than 32. Okay, this is will be 2 to the power of 5, refinement level of 5. Okay, so this is, you start to see that here, this would be a direct conflict with the growth rate, the transition. So if by any combination that you do, you see this one that is more than 33 or about 30, it is going to fail. So here, roughly speaking, I know that in 20, it is going to fail my boundary layer meshing. But also you have another one, which is the ratio. This one has to be less than 32, less than 100. This one. So this is the ratio to the surface edge cell size to the normal distance now. And then here, well, I have some corrections. I mentioned that I modified my snappyHexMesh and I added a few numbers. So I add a correction and it works. But I don't recommend to do how I do it. So this is just to fix the problems. I learned to live with a small error. So for me, having a small collection is not a problem. So this is a work I did a long time ago. This one will have a limit of about 100. Okay, so just to make it clear, will be the ratio between on the surface, the edge, okay, the largest one, by the way, to the distant normal. And that is very important in turbulence modeling and so on. Okay, and that one, okay, so we were looking at is fixed, no, in the Excel should be no more than 100. When you start to reach 100 or 200, no, you see that the transition from 100 to 200 is super fast. This OC3 data structure. But roughly speaking, you hit this limit 100, likely is going to fail. So here will be the first one you reach. So if you reach this one, you know that in this, you cannot add more than 20 layers because it's going to fail. And then there is another hard limit, okay, which is related to the aspect ratio. You don't define that in all these quality metrics. Remember that intrinsically in OpenFOAM is fixed to something about 1,000, and that will add a very hard limit. Okay, hard limit. All this transition now to have something less than 1,000 means that you need super fine meshes here. So all the problems very often happens due to that aspect ratio. Okay, so I'm going to show you a small trick, not recommended, but if you want to see boundary layer, you will see. But roughly speaking, this is the limit that you can reach distant normal in meters. So 10 to the minus 4, roughly speaking. Many cases, this is okay. Some cases, those working in naval application, probably you need to go 10 to the minus 5, 6. Okay, so that is a limit. So let's see how we can improve that. So these are, okay, I need to clean up this, by the way. I have many comments here. This is, as I mentioned, this was a while ago. I worked at the modify something. Design you can do for the first cell. So here you have the same stuff. You have the comments, what are your limits and so on. Here you get this distance. You already know this is your near wall distance. Then you have your total thickness and so on. So roughly speaking, same criteria. So this is really relative distance for axles. Pretty much is the same concept. So I feel more comfortable working using relative. Okay. So let's take a look here. And what I'm saying that if I put 20, it is not going to work. So let's see what happens. Okay. So bam, 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 bam here. And let me put here 20. And I'm 100% sure that it's not going to work. So remember that I'm going to do a restart. I'm not going to do everything from scratch. Erase that one. And then let me launch snappyHexMesh. I want to rig a specific input file, which is snappybl. Okay, just this one. And there you go. I know it failed. See that you have all this reporting and you can take a look. But first, let's take a look at this one. With 20, as I mentioned, these are standard geometrical progressions, very easy to compute. But then you have all the other relations that you need to get and quality metrics. So here, near wall distance for 20 will be, roughly speaking, this one, and your total thickness there. So you got it. And then I already know that here you are hitting this limit. It's going to fail. Also, I know I'm having in this case problem with the aspect ratio, and here also, while this one might work, this ratio, I'm hitting this limit here. So no need to visualize, but I will do it in any case. So here you go, bam, bam, bam. There you go. So it worked here, everything collects, but the problem here, well, basically is this conflicting quality metrics. So how can we fix this problem? So actually, just to show you, for instance, if I go here, let's say 18 likely is going to work. Let's see. BL. Okay, go there, BL, and it worked. Okay, so usually you know that your limit is this one. Don't go to 19 because also that one might not work. Go 2 levels below, and it worked. So kind of already you're having a verify. This is a fine mesh. So look at that differential distance. We look. There might be some problems here and there, in particular in the leading edge, but you need to learn to live with those issues. Okay, that's not a big problem. Okay, let me go here. But see that this is already nice. And here you have that issue. Everything related now, how to control excuseness. Here there are many issues, excuseness, aspect ratio, and orthogonality. So it's doing all those checks. So the only way is to disable everything, and that might give you problems. So there you go. No, you have that trick. It will work in the same way with first relatives. You always hit some hard limit. Okay, so you can play around with all these combinations, and you will see. No, that seems works. But let's say that I want to go to this value, 10 to the minus 5. 30 layers in this case, or you can change something, but let's say that, let me point 30 layers, and this is what people say is okay, it's impossible to do with Snappy, and it's partially true. Erase this one. Let me go here. It will do everything, and it's failing. Okay, I know it's failing. So I'm going to show you a few ways to fix this issue. Okay, it's not a perfect fix, and let me give you a big warning. Oh, okay, that is not perfect, but if you want to get a better coverage, you have it there. So the first thing is that is to read here now what is happening. Now I'm doing the mesh, and you start to see all the quality metrics, what is happening. You start to read here, and you can start to identify some errors now. So if I go here, okay, bam, 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 nothing here. I go here, and it's already telling me that there is something happening here. This is a warning here, some quality metrics. I start to get an idea that there are some issues somewhere. And here, after we'll do this iteration, it will small. So remember that it's everything controlling or using mesh quality control, all those options, and it's trying to improve that. It's doing many iterations. But then if I keep reading, look at I go here and I hit precisely this one, the phase determinant. Oh, okay. So you can go to the user guide. Probably you're not going to get much information. You read the source code, and maybe it will be clearer for you if you manage to understand that. But that is strongly related with the aspect ratio of the boundary layer. Okay. I just want to point out that there is around a very nice presentation. There are many presentations, but particularly this one, I will add it also in the sources in the resources. Okay, here you have a tool of a snappyHexMesh. It's a little bit old, but it's still valid. So here they show the mathematics, a little bit the equations of many of those parameters. So you have it there. So if you want to avoid reading the source code and entering in details. So for instance, let's see that if they have that determinant here, quality, da, 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 da. So this one. So roughly speaking, this is what it's doing. Okay. So let's see how we can fix. The first things that we can do, I know that I have a specific metric for that and here. So let me disable and let me put -1. There you go. Problem solved. -1, it is disabled. Now, let me run checkmesh, and you will see that. Recall previously we didn't have any problem or problem orthogonality with that. That is okay. But let me show you now the issue that we're going to have. And this is, you will relate it very easily, that aspect ratio. So now you have an aspect ratio of 3000. So one of the modifications that is kind of hardwired in OpenFOAM. Okay, so I changed that one and avoid that limit, but it's hardwired to 1000 and you have it there. This is not a problem. Remember, this is just telling you that you have a super fine mesh. Then no orthogonality. Okay, but it's not a problem. And let me go there. We put here, go here. Ah, go here. And there you go. So as you see, super fine mesh, problem solved. 30 layers, and clearly you see that the aspect ratio is very high, but it's very high simply because this distance is very small and then the edge side is very large. How do you fix that problem? Well, you need to add more surface refinement, and we have seen that that can be very expensive. So in this case, to go to 1000, you need to go from 4 to 8 to 7, if I will recall. Around this case, you go to 7 and it will fix the problem. 7 is something incredibly slow. You will get a crazy large mesh, not something, it is an overkill. But then you're going to have these problems here. This is super difficult to solve, okay, by the way. So you can disable quality metrics and so on. So there are a few options that you can play around, but it's tricky. So as I say, I learned to live with that. One solution also is to use the other geometry that you have a straight leading edge there. So usually this problem, you have it there. So you have the first solution there, okay? There is another way, so by the way, this reporting that you see here, not always, sometimes it's not very clear to identify these errors. You need to get more output information. By the way, there is another option here, this one, additional reporting. So this is extra debugging from boundary layer. So it will give you more information. So read this, and here you can, very often you can identify, who is the culprit, and then you can add directly, in these input files, or if you want, you can modify your source code. By the way, just check now here, look at with 30, we have roughly speaking this distance and the total distance, okay? So roughly speaking, so we're okay. So the other way to do it, and strangely, is the way I like, remember, this geometry is very easy, so we can identify sometimes this log file is super complicated, it's difficult to move around, or you can look for the keywords. No, we already know that this determinant, it is in a specific keyword, so you use grep and look at this, you have information. So there are a few specific keywords that you can identify and look for that. But the other option is to disable this one. This option is the responsible to do the iterations to enforce these quality metrics. So basically you're telling here, do at most 50 iterations trying to enforce everything if one of these checks fail. Okay, so here is doing, I think it's doing 2 iterations, and the second enforce everything. Okay, and just to show you, let me rerun. Okay, I erase the negative option of the determinant, by the way, I think, and see that it's failing. Okay, it's doing a lot of function iterations, more than 2. It's enforcing, but it didn't manage to get anything. Okay, the issues, what you can do here is disable this, put 1. You need to do at least 1. So basically, if you put only 1, oops, by the way, I need to erase that. You disable that check, and you are ready to go. So basically, it's just doing the mathematics, boom, 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 but it's not doing the enforcing the quality checks. Probably this is way when things are super complicated. Disable that check there. So if I go Paraphone, exactly the same mesh we're going to have. Okay, everything perfect. Okay, except here. So this is the other option. Strangely, I like to use this one, but probably if you manage to identify a specific quality metric, and most of the time not working with the boundary layer, you know that it will be the culprit will be this one. So you can disable this one. Playing with some other might help. There are some specific cases I know precisely, but most of the time will be the main determinant. And another one that can help is this one, but it will help. Okay, so read the documentation, you will see what it's doing, but it's not in a good way. Kind of brute forcing will do it. So let me put it. So many times it will help in a positive way, many times in a negative way. In this case, actually, I don't recall. Let's see what we have. It's not a good solution. So it's just a check mesh. And this is what is happening. So see that is growing here, but then when I start to have the problems, and here this one can help you to identify, those problems, aspect ratio, transition. You start to have the problems here, see that it forces layers to grow. Okay. So some cases might be a solution, some acceptable. I don't know. It will be up to you, but you have these three options. Okay, so as I say, there are a few other ways. Then you can modify the snappyHexMesh. I have my own modified version, many different options, but it's not a perfect solution. So I don't like to share that. And also, but it's part of our know-how that we prefer to keep in house. The other thing that I want to show you, so we have this. I hope you're getting an idea how to solve this issue. So at this point, you can revisit the cylinder. All the problems that you were having in that cylinder would be fixed. No, like by using these techniques. Then let's say let me go 10. So let me go 10 here. That it will work. Okay, so let me go put 10 layers. So as you see, I'm not getting lost in all the auctions. I know every of these auctions for a specific cases will have a specific weight and influence in what is happening. I'm just showing you the most important one. This one is also important, particular for the collapsing. In this case, it will help a little bit, but it's not your final solution. In some other cases, it will help a lot. So let me put 10, okay? So 10 from this one is telling me that this is the first cells distance. As you go there you go. Coverage, I know that it will work. So there is another technique, okay, that very often I use, okay, and also it's based in progressions, geometrical progressions to refine your boundary layer. Okay, I left one section here. Let me go. This one should be 0. 0 for, okay. There you go. So I know it is working, it's fine. I have this distance, the first cell's distance, and so on. So the other option that we have is something called refine wall layer. Okay, so this one will split the wall layer according now to a progression that you give. So it works like this. The name of the surface, STL surface. Remember, you can always use FOAM info to know how it works and so on. And then you give a progression. 0.5, 50% of the cell next to the wall. So you apply your geometry, you know that distance, okay, in this case is 10. And if you want to keep this growth rate of 1.2, write your small progression and you have it here. I will throw values randomly. So it will take the last mesh that I have, folder 3, it will split it in half. Boom. Save it in 4. Do it again. Do it again. And here now, as you can see, you are not enforcing any quality metrics. Okay, this is brute force, split it in half. Let me go check mesh, latest time. Up. And here you go. So see that exactly the same problem, aspect ratio, even larger here, and problems with no orthogonality that now goes close to 89. For me, it's not a problem, but let's see what happens. So I know precisely also where I have those cells, so you can also check that. And I would refresh your memory also to do that check. So those cells will be here. Okay. And look at that. Now here we solve that problem also. But see that you split the cells. Usually this skewness, recall the definition, you will have it here in this chance here. So, and there you go. Problem solved. To remind you that I didn't apply any progression here, but it's highly recommended to apply a progression. Okay, so there you have another technique, and let me show you another one. Okay, and let me erase also 9. So this stuff works very well. Always snap is you add one layer, it works very well. So probably you know where I'm going now with this, which I'm going to say. So I go like this. I will add just one layer. And now you can apply your refine mesh in this layer, refine wall mesh. You write your progression. So in this case, let's say that, let me put here, let me make it larger. So let me put here 2. So the layer next to this surface will be twice as large of the cell next to the wall. And now here, apply your regression wall layer. So it's up to you. And here you can go very, very, very low. So you have it there. By the way, also you can add you can add also manually the layers, using working like this, one single layer at a time. Also, it also works, a little bit more time consuming. Probably it's a good way to do it because it will enforce quality metrics. But when you start to hit these hard quality metrics that I have here that are hard coded, it will collapse. Okay, so then you need to disable something or modify something, but it will work. No, so you can go add another layer and keep going like that. By the way, let's see that at the trailing edge, and just to end here, okay, let me go mesh quality metrics. I was having a problem that maybe if I use this option, maybe it will help. Ah, okay, let me go here. Okay, it didn't help, but I'm not sure if I am forcing those. Yes, they are disabled. So sometimes it helped. In this case, it didn't help. It was that collapsing. So later there's a video to show you because there are also other specific techniques now for this kind of, the sync ups, how to fix that. Okay, but that's way much more advanced. But there you go. No, it didn't help much. So there you go. A new technique also to fix boundary layers. So if I show you a few methods, it's up to you. Uh, get familiar, play with these two cases. I will share this Excel script, okay? Probably will clean it a little bit more. And I like to use relative size. Okay, you can use also absolute. Remember, absolute, you give the actual distance in meters. So, well, thanks for your attention and see you next video. Bye.